Hi guys, I am Dr. Nandabalaji. Today we are discuss about the topic of lasers in the method of spontaneous and stimulated emission and population conversion method or population inversion method. And then introduction about of laser, it's a device, it emits light through a process of optical amplification based on stimulated emission of electromagnetic radiation. These lasers have a four different types of characteristics like as highly coherent, highly monochromatic, high directionality and high intensity. And the principles of the laser it's based on three separations like as stimulated emission of an amplification medium, population inversions of electronics, and optical resonator material. And what is the stimulated absorption? First of all, we know that the structures of the atom in lower level E1, energy state 1, like as an incident photon, and jump to excited state E2, like as our upper state or upper energy level. This process is called induced or stimulated absorption or simply absorption. The images like source the E energy is equal to h mu. H mu means Planck's constant. It's hits the electrons to jumping E1 to E2 or E2 to E1. It's splitted into many level amplified level. So the amplified level of E is equal to h mu is greater than 2 h mu is equal to E2 minus E1. And spontaneous emission like as the diagram shows the second part spontaneous emission. The part of atoms is jump to upper state to lower state. So that is we state the atom in the excited state returns to the ground state by emitting a photon of energy E is equal to h mu without any external energy. This is known as spontaneous emission and stimulated emission. In this figure shows the stimulated emission like as energy state upper energies to ground energy. The atoms will be down to upper to ground. The atom in the excited state returns to the ground state by external triggering or inducement of photon, thereby emitting a photon of energy equal to the energy of the incident photon, known as stimulated emission. And this is the stable state, it like as a metastable state. These are the energy states in which atoms can remain more than 10 to the power of minus 8 second are called metastable state. Like as absorption means ground state to upper state E0 to E2. In between of E1, it's like as a stimulated spontaneous emissions. So E0, we show the figure A absorption. E0 have a lot of materials like as a lot of holes and electrons. So E0 to E2, the material atoms will be transferred, the energy will be moved to the one place to another place. But in the spontaneous emission, the figure of B, it shows like as it's stayed in E1 state. And E1 state, it's like as metastable state. So these states will be gives the more work nature. So stimulated emission gives an upper state to lower state. It gives E2 state to E1 state. It's transfer to E2 to E1. It's bombarding to the energy is equal to h mu. It's amplified more than double, twice. And laser excitations like as the laser excitations means similar to the stimulated emission. And difference between the spontaneous emission and stimulated emission, two different types of work nature. One has a stimulated emission, has a atom in excited state is induced to return to the ground state, and another side of spontaneous emission, the atom is excited state returns to the ground state, thereby exciting a photon without any external inducement is called spontaneous emission. Like as this is resulting in two photons of same frequency and energy is called stimulated emission. And stimulated emission emitted photons move in the same direction and is highly directional. Spontaneous emission emitted photons move in all directions and are random. The radiation is highly intense, monochromatic and coherent of the stimulated emission. But the spontaneous emission's radiation is less intense and is incoherent. The photons are in phase, there is a constant phase difference. The spontaneous emissions photons are not in phase, there is no phase relationship between them. The rate of transition is given by rate of stimulated emission to 1, energy state 2 to energy state to 1. It's equal to B21 rho V N2. The rate of transition is given by the R energy state 2 to energy state 1 stimulated purpose SP, it's equal to A21N2. In this equation, we have to get a equations of Einstein coefficients, and this is the normal distribution and population inversion distributions. An upper state system will eventually give off a photon of the proper wavelength and drop off the ground state. These different types of figures shows the different types of temperatures, like as lower temperature and higher temperature. In lower temperature, all the atoms are stable in the one place. In the higher temperature, atoms are splitted in the all the states. This is the difference between of the normal distribution, population inversion distribution. Thank you guys. Thank you very much.